Welcome to the demo of the TEM auto processing tool in Workbench. It has been redesigned a bit for Workbench 6.6. First, I'll just show a few slides on why do we need to process the TEM data and what can we do. So, a quick background, again, how does the TEM method works? This is an example from an airborne survey, but it applies to all the different TEM instruments and methods out there. So, again, first we make a steady current in a transmitter loop, and it creates what we call the primary field. Then we shut off this current as quickly as possible. The quicker the better, because we can start measuring at earlier times, which gives more information closer to the surface. But when we shut it off, it creates eddy currents that goes into the ground, and these currents go out deeper and deeper in the ground. They will create a secondary magnetic field that will induce a small voltage or current in the receiver coil, and this is what we measure. And of course, this induced voltage in the receiver coil will reflect the geology and the conductivity of the ground where we are. So what we measure can look like this. The blue curve here would be the actual measurement, so it's a decay of the magnetic field over time. And the green curve here would be the natural background noise. And as you can see, they have different slopes. The background noise would normally have a slope of -1.5, and the measurements will have a slope of around -5/2. So the purpose of this is to remove noise and to remove couplings. EM is very sensitive to man-made installations, power lines, roads, pipes, and so on. So we need to remove these couplings in the data because it cannot be used, and we want to suppress the noise so we can use more of the data. The goal is, of course, to get data we can use in the inversion that don't give us any artifacts that could look like geology but are from noise couplings, and to help the persons who is working with data so they don't have to do everything completely manual. There are several types of noise. Again, the two main ones are the random background noise and noise from couplings. The random background noise, they can be suppressed by stacking. So if you measure for a longer time, if you raise the moment of the instrument, higher current, larger areas of the transmitter and receiver loop, you can suppress the noise. And we also add a spike filter to take out spikes when we do the stacking of the to suppress the noise. So what I mainly want to talk about now is the Trapezoid filter that we have. It's a running mean filter, and the reason why it's a trapeze shape. So first, if we take a box shape, that would be the normal way to go. So this picture shows you all the time gates with different colors. And the early times are at the top and the late times are at the bottom. And then you have a profile of 1.5 minutes, 2 minutes. So if you have a box-shaped filter, that for example could be for 30 seconds of data and we move it, or we can make a narrow one that is around 5 seconds. Then we will make a running mean of all time gates in the same time interval. And the problem with this would be, as you can see here, when I move forward and back, this is the raw data. This is the average data where we have been running the running mean filter. That you mean out the noisy data at the bottom, so you can actually maybe use some of the late time data, but you also smear out the information at the early time gates. So if you look at the purple one, the first time gates at the top, you actually remove a natural change in the data over the distance to be more simplified, and then you will remove geological information. On the other hand, if you take a very narrow box filter, you will keep the early time information in the first part of gates, but as you can see in the really late times, you don't really help getting much more out of this data because the box is not wide enough. So again, for the late times here, you won't be able to use the late time data using a very narrow box filter. and for a white box filter, you will smear out the information you actually want to use in your inversion for the early times. So we want the best of two worlds. We want the best of the large box filter at late times, and we want the small narrow box filter at early times. So we have the option to set up a trapezoid shaped average filter instead. You actually define 3 different widths within 3 different times, and then you can use this and move this. By doing this, you will get the early time information that is not smeared out by a white box filter, and you will also get the late times information you can use because the average filter are wider down there. So this was just to give an overview why we use the Trapezoid filter. Now, going back to Workbench. So when you're gonna use the auto processing tool, it's called Process Data. So you highlight a data node. And this is the new window that comes up. It's very different from the old one, and it's used for all TEM data in Workbench except the raw SKB file format for SkyTEM. That will be, it has been used a lot in the past. It's not used that much anymore, and SkyTEM and us are slowly moving away from it. But that format still uses the old tool in Workbench when that is opened or imported. But for all other TEM, we use this new tool. So going from the general settings first, again, you can choose which channel of the data you want to apply these filters on. There's only a few instruments that have several channels. One is SkyTEM, one is the ground-based TEM system. They have different channels with different currents. So you can select which one you want to apply which filters on. You can actually move the GPS location along the flight line because the GPS are not necessarily located on the instrument where you actually have the information, where you have the highest sensitivity between the transmitter and receiver. During import of airborne, it's actually put in as a pre-value that you can choose that you want to move it in a direction along the X-line to get the correct position. A new thing we have is you can actually process thing in distance if you want. This will be applied to the Trapezoid filter where you can, the width will be in meters instead of seconds. This is very useful, especially for ground-based EM systems where you tow it behind an ATV and you are sometimes not driving, it's standing still, and then you drive again. Then it's much better to actually use the processing in distance. So that's a new possibility we have. Sounding distance, if you have very raw data and you want to even out during filtering the location of the data, you can actually go in and say, I want a new data location for every, for example, 1.5 seconds. So when you have done the filtering here, then the average data will have a data location, a new data location for every 1.5 seconds. It's also possible to do in distance by meter. If you want to keep the data location as it is, we shouldn't put this on. If you have already done some manual processing, but you want to reapply some filters, you can say, I want to keep the manual processing I have done on our raw data, and it grays out the raw filters in here. So you can still do processing on the average data and keep the raw processing that will be applied to average data also. Then we go down to the processes down here. Here we have the different filters that can be applied to the data. Down here we have a description of the filters, and over here we also have a description of each setting within each filter. I don't want to go through each of the settings. Again, it's possible to press F1 and actually get a description of it. But to go through the filters over here quickly, the raw filters are used to remove couplings. That's the first thing you want to do on the raw data before you use the filters to create the average data. So there is a raw sign filter that removes if there is a sign change in the data. You actually set the noise level the background noise level, so you only remove it on data above the background noise level, because you don't want to work with the background noise level until you are on the average data. Then you have a slope filter, again, where you can disable data that has a different slope than the -5/2, that is the usual slope that you have for data. So you can set in some settings that will go through the data and remove slopes that are out of sight of these settings. Then you go to an altitude processing where you can remove outliers if they are extremely high or extremely low. It's a very simple filter. And then we come to the trapeze filter that creates the average data by going through the width of each trapeze, and you set the times of which time should apply to each width. During this, within each width, we also have the spike filter you can set that can remove. If it's set to 20, it means it takes 10% of the top spikes and 10% of the lowest values for spikes and remove them. Then we have, like we had for raw, we have a sine and a slope filter, but now we can do it on the average data. And now it is to remove the noise, the background noise that come at the late times. They work the same way, but now you can apply them when you have done the averaging. And in the end, we have a STD filter, a standard deviation filter, just saying if the standard deviation from stacking on some of the data points are above a certain percentage, we will disable them automatically. So this one, for example, says 1.4 equals 40%. So if there is a standard deviation or error margin on a data point more than 40%, it will be disabled. Again, we can load and save the settings and use for another time, and it will press OK and it will be applied to the data. I think I only did some raw sine filter and trapeze filter on this data, but if we go in views, and here we look at the raw data, here we look at the average data, and you can see that has been disabled where we think there should be couplings for the raw data. And there has been a meaning filter, so down here you have the average data, and you can also see that it is a bit more smooth for each channel than the raw data. One thing you will notice is there are still some weird artifacts around where the data can jump. So it's never really possible to apply filters that will process your data 100%. So you will still need to go through a manual processing afterwards, and that's what Views is for. Thank you.